The communication layer networks. Computer networking, a collection of computer devices that are connected in various ways to communicate and share resources. For example, there's a LAN. It's called a local area network. You have the ring topology, the star, and the Ethernet, which is also known as a bus. And you also have the WAN, which is a wide area network. And we'll talk about each in turn. A LAN, it connects a relatively small number of machines in a relatively close geographical location. So for example, if you're here at Morehouse College, the network you're on right now is considered a LAN. Well, if yours at Morehouse connecting to Georgia Tech, you'll be on a WAN because a WAN connects two or more local area networks over a potentially large geographical distance. Ring topology. Nodes are connected in a closed loop where messages travel in one direction. Nodes pass along the message until it reaches its destination. So if I'm starting here and I want to talk to this computer, I send it to this computer sends it to this computer, and then finally this computer sends it to that computer. The only problem with this network, if this connection is broken, it breaks the entire network in the ring topology. Star topology. It contains a center node to which all other are connected and through which all messages are sent. So I'm at computer A here, for example, and I want to go to computer B over here. I had to send a message to the center node, and then the center node forwards that message to B. And if B want to talk back to me, he had to send it to the center, and the center sends it back to me. The good thing about a star topology is that if one node dies, it doesn't affect the entire system. However, if the center node is taken out, then the whole system goes down. LAN, also known as bus topology or Ethernet, which is what we most commonly use. All nodes are connected to a single communication line that carries messages in both directions. Nodes check all messages to see if it belongs to them. So if I'm at node A here and I want to talk to node B down here, I send a message on the Ethernet, and the message goes this direction and it goes in that direction. And every computer is listening to see if the message is for them. If the message is not for them, they don't touch it. But if the message is for them, they grab it and they send it down to their computer. That's how the Ethernet works. You may be thinking, well, that's not secure. Everybody's listening to my messages. Yeah, it's really not secure because everybody is listening to the message. The goal is only to pick up the message that are just for you. Now, remember, a WAN is a connection of LANs, and you want to connect LANs together, you need a thing called a gateway node. A gateway node, for example, on this say network A, and we call this network B, and this is network C, and we want to talk to these LANs together. So I send a message from this computer, it goes to my gateway, the gateway sends it to this gateway computer, and this gateway computer sends it on to this next network, which sends it to the computer that we're trying to reach. Let's say I want to talk to this computer, and so this computer will send a message to its central node, sends it to the gateway. The gateway then sends it to this computer, and this computer sends it to that computer. So the gateway nodes are the nodes that allow you to connect outside of your network to other networks. The internet connections. No single person or company owns the internet or controls it entirely. It is a wide area network made up of many smaller networks. Internet backbone refers to a set of high-capacity data routers that carry internet traffic provided by, say, AT&T, Verizon, etc. Smaller networks connect to the backbone to connect to each other, and this word should be connect, not content. So here's a picture of the internet backbone. So don't try to read the whole thing, just let you know it's vast, and the network even goes across the ocean, as you can see here. Internet service provider, also known as ISP. They're a company that provides other companies and individuals with access to the internet via the backbone. For example, remember AOL, when you had to dial in to AOL and you had to connect to the internet? So there was internet service providers that would connect you to the backbone and then connect you to the other people on the internet. Types of internet service providers. You got phone modems, DSL, and cable modems. Let's talk about each of the three. A phone modem converts data into an analog signal for transfer over a telephone line, and then a modem at the destination converts it back to data again. The data transfer rate is limited to that of analog voice communication, which is usually 64 kilobits per second at most. So basically, is basically using your exact same phone lines, and when you send in digital data over the phone line, it has converted to analog, and analog goes over the phone lines, and then it's converted back to digital on the other side. Now, DSL uses the exact same phone lines. Now, it transmits digital signals over regular telephone lines because DSL, which stands for digital subscriber line, and voice communication use different frequencies. It is possible to use the phone line for both purposes at the same time. However, a filter is needed on each phone line to filter out the digital frequency. So unlike the phone modem, we're using the exact same lines. We don't have to convert it into analog, which makes it a lot faster. It goes straight from digital to digital. Cable modem is a digital data is transmitted over the same line that your cable TV signal comes on. And so it's pretty simple. The same line is used, like say for Comcast, you get movies and TV, you can send digital data on to the internet. Both DSL and cable modems fall into the categories of broadband connection, which generally indicates data speeds faster than 120 kilobits per second. Packet switching. To improve the efficiency of transferring data over a shared communication line, messages are divided into fixed size numbered packages. So what does that mean? So you start with a message. That message is broken up into packaged. For example, let's say we break it up into 3 packages. Those packages are sent over the internet by the most expedient route. So they're not sent along the same path. They just send them in any path to get there. So it's almost like you and your friends, you guys are trying to drive down to a beach somewhere. So instead of following each other in a long line, what you do is you break up and say, here's, everybody has directions, just get there and we'll meet up when we get there. And then packages are reordered and reassembled when it gets to its destination. Firewalls. Software on a gateway machine on a LAN that protects the LAN by filtering the traffic it allows in and out of the network. So if this is the gateway, whatever tries to come in here, this gateway is blocking it and not allowing the traffic to come in. It first checks it and sees if it's good. And if it's okay, it'll send it on into the system. And when information needs to get out of the system, firewall will determine where should it go and how should it go. Network addressing. Communication with a computer on the internet requires that each computer has its own address, just like a mailbox. For example, blog.morehouse.edu, which is each host name corresponds to a particular IP address, which is made of 4 numeric values separated by dots. So for example, and this is not true, but the blog.morehouse.edu is converted into an IP address of numbers. You see it's 4 numbers separated by dots. So actually, if you type this into a computer, you should get a web address. Now, I'm not saying this is actual numbers, it's just for example's sake, but when you type in the numerical IP address, you actually get the website you're going for. So the question may be, why don't we just type in numbers versus type in a name? Well, it's easier for people to type in names and remember a whole bunch of numbers. So that's why we use names instead of numbers. But because we're using names instead of numbers, we need a thing called domain name system. It's a system that is used to translate the host names into a numeric IP address. Domain name server, which means short for DNS, is a computer that attempts to translate a host name into an IP address. Now, there are multiple DNS servers around the world, and no one organization is responsible for updating the host name and IP mapping. So basically what happens is you type in, say, morehouse.edu. It goes to a domain name server, it looks up the IP address, and then it forwards that information on to the correct servers where that information is being held. Alright, that ends our lecture for today.